For left brains, here's how I remember the rules. If you're adding logs, it becomes multiplying. Dropping to the last one, if you're subtracting logs, it becomes division. And any exponents become coefficients. Adding becomes multiplying. Exponents become coefficients. Subtraction becomes division. Take out your formula sheet that we haven't used now in 3 units, 4 units. Why do we have these log laws? Well, we're going to do 2 things today. And again, this is prep to be able to solve the equations that are coming. We're going to use log laws to simplify. Because mathematicians, we love to simplify stuff. And then we're going to go backwards. And what's the opposite of simplifying? Expanding. So we're going to use log laws to simplify and then log laws to expand.
What's this 4th law that's written on the formula sheet?
I don't know which one's the 4th. Can you read it out to me?
Log base A m equals log base B m over log.
Oh, that is your beloved formula for the calculator. We're not talking about it till tomorrow, but there, you can look at it. So first we're going to do the simplifying, then we're going to do the expanding. So this is just like way back in grade 9 when you first learned the exponent laws, and we spent days and days and days simplifying expressions that had power laws and product laws and quotient laws. Same thing we're just doing now with logs. So we are going to simplify log base 4 3 plus log base 4x. And what simplifying means is at the end you should have 1 log with 1 base with a whole bunch of crap after it. You should only have 1 log, 1 base, a bunch of stuff. That means simplifying down to 1 log. This one is the the product law, and it says that if we are adding, adding becomes multiplying. So I can squish all of this down into log base 4, 3 times x, which is 3x. That's straight up product law. If I'm adding 2 logs, I can simplify them down into 1 log, and I multiply their values. Example number 2, same law, we're just going to add in a 3rd term. Log base 2x plus log base 2y plus log base 2m. Simplifying, again, means getting smaller, so you're ending up with 1 log, 1 base, and a bunch of stuff after that. So I can simplify this all down into log base 2. And because it's adding, I can just smush them all together as multiplying. X, y, m. Questions so far? Example number 3, we're just going to add some coefficients in front. So 4 log x plus 2 log y. And what we're introducing here is power law. And power law says if there's an exponent, it becomes a coefficient. Coefficients become exponents, so it works both ways. So first thing I want to deal with are these coefficients right here. So the 4 is going to move up and become an exponent. I'll get it. The 2 is going to move up and become an exponent. That's power law. So that leaves me with log x to the 4 plus log y squared. Okay, so coefficients become exponents. Now I can go even further because I'm adding two logs together. I can use product law, and it says that if I want to smush it down into one log, what do I do with the two values?
Log x 4y squared.
That's it. So coefficients become exponents, adding becomes multiplying, and we'll see in a second subtraction is going to become division. Base is 10 because we don't see it, absolutely. Number 4. 2 log base 5x minus 3 log base 5y. First thing that we deal with are the coefficients. Coefficients move up and become exponents. So this is going to become log base 5x squared minus log base 5y cubed. Then this is quotient law. Quotient law says if we are subtracting logs and we want to simplify them, we end up division. So I'm going to have a log base 5, an x squared on the top, and a y cubed on the bottom. How are we doing so far? Really, it's this easy. It's not going to get any harder. This is it. Method. Move coefficients to exponents. 2. Move coefficients to exponents. And we do that step first simply because it's bedmass and exponent becomes before multiplication and addition. It's just simple bedmass. Adding becomes multiplying. Subtracting becomes, there you got it.
What would you call, you know how thing attached to the after the log is
The value, we call it the value, so the base and value. Number 5. Log base 3x plus log base 6m. And there's a note after it, so clearly that's going to be important. Note. What is different in example 5 than example 1, 2, 3, and 4? The bases are different. So if we go back and look at our log laws, check out the bases. A, A, A. A, 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 A. Do we have a rule now when the bases are different? We do not. You cannot use these laws with different bases. On the exam, they'll tend to throw in one like that as a multiple choice to see if you're going to catch that the base is different.
you don't like
So what do? How do we simplify this? We can't. It's already simplified. This is as simple as it can get. Just like with our exponent laws, we can't combine an x squared with a y to the m. There's no way to connect them if the bases are different. So if the bases are different, there's nothing we can do. It's done, simplified.
You can't use the log laws with different bases.
I enjoyed that one better. That had a better ring to it. I feel like making posters of those with Andy's face on it. Number 6, 2 log x. Minus. 3 log x plus 2. What's different example 6 from example 1, 2, 3, 4, 5? Yeah, but so we're 1 through 4. Yeah, it's got this binomial here. Don't let that freak you out. It doesn't matter. It's still just a value. Steps are going to be the same. Any coefficients become exponents, so the 2 has to go up and the 3 has to go up. You notice I'm not moving that negative. I'm not taking negative 3. I'm just leaving it. So this is going to become log x squared minus log x plus 2, and then the cube just goes at the back of the brackets. Bless you, bless you. In a second, yeah, I'm just doing it step by step. So you might want to make a note is don't move the negatives. When you move the coefficients, the negative stays. Okay, and this bracket at the back, don't care. It's just a value. Now we just need to finish up. What happens when we subtract logs? We divide their value. So I've got log of x squared on the top, and on the bottom, x plus 2 cubed.
Oh, goody, irrational.
Yay. You could multiply out this x plus 2 cubed if you wanted to, but there would be no point. So on the exam, they won't ask you to. It's not going to get you any further. There's no reason. We can just leave it as a binomial cubed. Note. You cannot, and I even bolded the not, distribute a binomial that comes after a log. So in the question where we had log x plus 3, you cannot just say this is log x plus log 3. And you're going to want to do it because it's what we've done with binomials all the way up to grade 12. But it doesn't work that way. Remember sine alpha plus beta? Like way back in October. And we were like, well, we can't just multiply through that sine, and that's why we had those huge long sum and difference formulas. Same deal here. Sine was a function, log is a function. You can't distribute a function. You can distribute a variable, you can distribute a number, you can't distribute a function. It doesn't work that way. Okay, so if it comes after the log, you don't touch it, you just leave it exactly the way it was, it follows along and all the way to the end. Take a look at number 7. How is number 7 different than number 6? It comes before the log. Well, in example 5, with the second piece with the binomials, we were taking the log of this entire bracket. That's why we can't distribute it. Here we're multiplying a binomial times a log value. That you can distribute. So if the binomial comes at the back, no touchy. If the binomial is at the front, distribute. Okay, so if a binomial comes after a log, don't touch it. If the binomial comes in front, distribute. So what we're going to do first is distribute this log base 4x through this binomial. So we're going to end up with x times log base 4x plus 3 times log base 4x. And then I still have that minus 4 log base 4y. If the binomial comes after, don't touch it. If the binomial comes before, multiply it out. Turn to a friend and explain to them or discuss between the two of you, why could we distribute in example 7 and we couldn't in example 6? Okay, what do we do now that we've gotten rid of those brackets? Well, same step, so any kind of coefficients become exponents. So this is going to become log base 4x to the x plus log base 4x cubed, and then minus log base 4y. And x to the x might look funny to you because we don't see a lot of that. It's a value. We're okay with that. Just taking any base and raising it to the same exponent. The last step. Well, what do we do now when we have an add and a subtract? We simplify the adding as multiplying, and we simplify the subtraction as division. So I'm going to have log base 4. X to the x is going to be on the top. X cubed is also going to be on the top. What about y? He goes to the bottom. So anything you're adding goes on the top of the fraction. Anything you're subtracting goes on the bottom. Can we simplify this? Yeah, that's just an exponent law from grade 9. Exponent law from grade 9 says if you're multiplying bases, what do you do with the exponents? Add them. So I'm going to keep my log base 4. I'm going to keep my y on the bottom because I'm not touching him. All I'm going to do is simplify the top, and it's going to be base of x, exponent of x plus 3. Waiting.
Can't you just put the x plus 3 on the first step as an exponent?
Yeah, absolutely. Yeah. Yes, but there's times it's not going to work.
Why?
You don't know that yet. So yes, you could have actually moved this at the beginning, but there's times it won't work. So yes and no, does that answer your question? I guess I'll let her in. I guess so. Hello. She's very sorry. Okay. She wasn't here for me, she was here for you. No, behind. Yeah, she wants you when we're done the notes.
That might have recorded.
No, What does that look for, Shaz? Oh, very good. Number 8. Oh, lots of stuff going on here. Log x squared plus 1 plus log x minus log x plus 5. So the first question really becomes is, can I distribute through those brackets or not?
No!
Why not? Let me down here. You know, I expect you just to come out with these really quickly.
I'm just gonna double check.
You cannot distribute a binomial.
You can distribute a binomial that comes after a log.
Yes. Okay, so no touchy. So if we can't, oh, yes, Ian.
What exactly is that?
Because we said so.
Okay, so this means you're taking the log of everything in brackets. So then you would have to do brackets first with bedmass. When we've got the binomial in front, this is a number. You're taking log of x and then you're multiplying. So the difference is you're logging what's in brackets. Here you're multiplying by what's in brackets. Okay, so if we can't distribute the brackets, what do we do then?
Nothing.
Yeah, we just go to the rules. Any coefficients become exponents. So this 5 has to move up, become an exponent. After that, anything positive goes on the top of the fraction. Anything negative goes on the bottom of the fraction. So the x squared plus 1 on the top or on the bottom? On the top, because he's positive. The x to the 5, top or bottom? Top, because he's positive. The x plus 5, top or bottom? Bottom. Now I could multiply this out and I could try to simplify. There's no point. It's not going to get you anywhere. So we just leave it like that. That's simplifying logs. That's about as hard as it's going to get. Try number 9.